So we have a function.
I'm ready.
We have a function in the first quadrant here. I want you to visualize for a second. We take this line and we rotate it about the x-axis. Okay, so when we do that, it will make a shape, something like what you see here. Everybody visualize that, okay? So now, I'm going to draw a little rectangle. And I want you to visualize, if I were to take this rectangle and rotate the rectangle about the x-axis, what shape would it make?
A cylinder.
It's three-dimensional, so the base is a circle, right? But the actual shape would be a cylinder. Okay, and so you can see that if you look at the notes here, this red shape right here is a very thin or short cylinder. Okay, so if you rotate the rectangle over the x-axis, your shape becomes a disc on its side, which is really a short cylinder. Okay, so let's look at the formula for a volume. The formula for volume of a cylinder. It's going to be the base, which is a circle, pi r squared, multiplied times the height. Okay, and so the length of the rectangle is denoted by the y value, f of x, and f of x is the radius. So let me go back up there. If I take this rectangle and rotate it about the x-axis, the base is going to be a circle, and the distance from x up to the curve would be the radius of that base. Everybody see that? So r squared comes from the actual function, and then my notes got a little wacky there. The height or the thickness of the rectangle is going to be denoted by dx. And I will show you why. Okay. So if we wanted to find the volume of one disk, we're going to use the formula pi r squared h, plugging in those values, right? But if we wanted to find the volume of the whole thing, that would be the shape of this purple thing right here. We're going to integrate that from point to point. Okay, so it's given by the integral from a to b, and then we have pi, and then I'm going to plug in f of x for the radius, and that's squared. And then dx denotes that it's with respect to x, and that is going to give me the height of all of the rectangles because I'm integrating from whatever point is right here to whatever point is right there.
I can put the h again for the pi r squared times h.
Okay, I put the h right here because this is the formula for the volume of one cylinder. Okay.
Oh, that's just like the general formula.
Yes, that's the general formula. Okay, so this is the formula that you will use to find the volume of disk. Okay.
The whole thing? Is that what you're talking about?
Yes.
Yeah.
So let's take a look at that. Rotations of disk on the x-axis. Example 1, find the volume of the solid in quadrant 1, generated by revolving the region of y is equal to the square root of 4 minus x squared between the graphs of y is equal to 0 and x is equal to 0 about the x-axis. So first, What is this? Don't say it's a square root. Don't say it's a parabola. It is a function, but what type? What shape is it?
No, it's not. Yeah, it is.
Eliza is correct. It is a semicircle.
Oh my God. I'll just like a rectangle.
A circle is x squared plus y squared equals r squared. If I solve this for y, I've got y squared equals 4 minus x squared, and then I take the square root of both sides, which gives me that. For the positive, the square root's plus or minus, right? And since there's only one positive, it's a semicircle that's in quadrant 1 and 2 with a radius of 2. Okay, we know that from either geometry or I did an example earlier in the course. So let's sketch the graph.
You're not simplify that though.
No. We do not. So we're talking about the shaded region here in the first quadrant under the curve of the semicircle. All right. And so they asked me to find the volume. So volume equals pi times the integral. And I need x bounds. My bounds are from 0 to 2. I know that because the radius, there's two ways, okay? The radius of my circle is 2. Okay, or you might use the calculator to find the intersection point.
Or how do you know the radius? You just did that thing? You just plug it in. Okay. Or that thing too.
X squared plus y squared equals r squared. Guys. All right. Pi times the integral. And then I'm going to go back to this formula. There's my formula. Volume equals pi integral from a to b. A lot of times they will move the pi out because it's a constant. That's fine. All right. And then we have f of x squared with respect to x. So I just need to take my equation, f of x, plug it in, and square it. So this is going to give me the square root of 4 minus x squared. Then I square it. We always square it because this is the radius, pi times the radius squared. And then the dx gives me the height of the infinite number of rectangles, in this case from 0 to 2. And I guess this probably should be non-calculator because I can simplify this to just 4 minus x squared. The square root of the squared cancel each other. But I guess I'll let you use your calculator. All right, so take your calculator and let's do math 9 and get our answer there. Hold your own weight, man. You too.
16.75. That's what I got.
So you should get 16 over 3 pi, or is that 16.755?
This isn't that bad. This is okay.
Okay, so this is just like a separate question. How do you make the calculated fractions and fractions?
It's second answer, or sorry, math.
Math.
You've got to get the answer. So if the answer is already in there, right? If it's not, you can get, go to math, and then it should be a fraction. Does that get it?
It doesn't give us like with pi. It does.
Okay. Well, here's what I would do then. Okay, you can move the pi out because it's a constant, and then just integrate that. but you have to make sure that there is a pi there, okay? This is a careless mistake that a lot of students make, all right? There has to be a pi because the base of the disk is a circle. So pi has to be there at some point. And a lot of students will forget they'll move it out and then they'll just integrate that and just leave off the pi, which is 16/3. But if you move it out, you can integrate that, get an exact answer, and then just stick the pi in there. Yes.
So just my side question is like I did the answer fraction in their math and everything, and it still comes up with zero.
What?
Like I did
I
it.
was too lazy to watch it.
Okay.
Oh, that happens.
You should be able to like put it, at least on the Inspire, you can put a dot there and it will give you an exact answer, but I'll look at it in a second.
I have a question.
Yes.
Again. So normally, like last unit, we would find from top to bottom.
Uh-huh.
But you just
Okay, in this case,
not do it because the radius.
no, in this case, the bottom is the x-axis, which is 0. But we will do top to bottom in just a second.
Okay.
Okay. All right, next one. That was about the x-axis. This time we're going to rotate it about the y-axis. So it says, find the volume generated by revolving the curve. X is equal to 2 over y plus 1. Around x is equal to 0, bounded by y is equal to 0, and y is equal to 1. So I want you to sketch a graph first. But what I need to do is, in order to graph this on my calculator, I need to solve this curve in terms of y equals. So let me do that. I'm going to cross multiply. X times y plus 1 is equal to 2. Then I divide by x. So I've got y plus 1 equals 2 over x, and subtract. So in order to graph, on the calculator, all right, I'm going to write it like this, put that into your calculator, and then make a little sketch of the graph. And you should get something that looks like that. And so we are talking about this area here between those curves as the shaded region.
When you put it into the calculator, you put the new one that you solved or the original?
Put in this one. Y equals 2 over x minus 1. Otherwise, you'll get an error message.
Wait, did you have the straight line just because it says
it's bounded by y is equal to 0, okay, which is, and y is equal to 1. That's why. Okay, so now whenever I'm integrating this, I am integrating with respect to y. Therefore, I must have y bounds in my integral. And I know that the y bounds are from 0 to 1 because they give me that right here in the stem of the problem. So those are my bounds. And then also, since it's with respect to y, I have to have y's in my integrand. So I'm going to go back and use the original equation because it's solved for x. And so I plug in 2 over y plus 1. So that's my radius, and then it is squared with respect to y. So now you can put this directly into your calculator. So go ahead and do that for me.
That's exactly what I got.
You mean 2 pi? That's what you got?
Ooh,
right? Don't get on to her when you didn't even do it. Pull your own weight. You should get 2 pi.
I didn't square.
So every time you have to like put it in terms of y to put in the calculator. Because Logan told me one time that you can just plug it in like it is, but you know.
You can. You have to use your alpha key to put in the y. But as long as you do it with respect to y,
But
the
can't you
calculator
do
will still
2
do it.
over x plus 1, 2 dx, and it's the same?
Yeah, that's what I was saying.
This,
No, Y bounds. Like if,
No.
like if you.
Oh, you have y bounds, Joe. You know what I
yes,
mean?
Okay.
you have to put it in terms of y.
Okay.
Because we're rotating it about the y-axis.
So pretty much whenever we have a graphic one, when it's in terms of y, or in terms of when it's x equals,
Couldn't you just put any?
should I just flip it around, put it y equals?
I did that in order to graph it on the calculator so that I could look at it. Okay,
Yeah, but
but if it's already solved in terms of it, mhm,
Eliza does it that way. You can put it as
you
as
can,
long as you put it with respect to X.
yes.
oh, okay.
Yeah, 'cause
Oh, hold on, I understand
what I
your
was-
question,
yeah.
okay.
Yeah.
Could I leave it like this and put an X
Yeah,
in
yeah,
right
yeah,
there
yeah.
and then a DX right there? Absolutely.
Okay.
That will work.
'Cause it's just
Oh,
variable.
okay. But
Mhm. Right, it's just a variable. The calculator doesn't
I need
know.
to put
Just
X
as long
in.
as it matches up right here.
Okay.
Yes,
okay.
that's correct. Okay, let's look at the next page and talk about washers. And of course, a student asked me, what's a washer, Newhouse? And I'm like, something you put your dirty clothes in, right? I mean, I just couldn't resist that.
That's
No.
All right, but when I talk about a washer, we're talking about that
Oh.
little metal disc with a hole in it. So we got, looks like a donut. We got the outer part. We have the hole in the middle, which is the inner part. So
That's a fun shape. That's in the house. Looks funner.
So think about this for a second. Look up here. I have a region. It's bounded by two curves. I draw in a representative rectangle there, which is red. If I take that and I rotate it about the x-axis, okay, here it is. We're filled with rectangles here. That red rectangle will make a washer. And you can visualize that right there. And the reason it is a washer is because from the bottom of the equation to the x-axis there is a hole. So when I take that and rotate it around, it makes a washer, which is a disc with a hole in it. Okay,
So it doesn't matter what the other shape is?
doesn't matter about that.
What the green shape is?
No, it doesn't. Okay, what matters is whether it is a disc or whether it is a washer. And so I'll get to that in just a second.
So it'll always make a hole, like a little circle.
If there is a gap there, okay? But here's where let me show you where the formula comes from, okay? So we have the volume of the outer part, which is pi times the integral from A to B. And we have the top equation squared. Then we have the volume. We'll call it the inner part, the volume of the inner, which is pi integral from A to B. And then we got a separate equation, the bottom equation, and that is squared. And so in order to account for the hole that is generated, we're going to take the outer equation and subtract the inner equation. So combining these two, I have volume of the washer. It's going to be pi times the integral from A to B. And then I've got the top equation, f of x, which is squared. minus the bottom equation, g of x, and that's also squared with respect to x. So you take your top equation, square it. You take your bottom equation, square it. Subtract those two things. And that will give you the volume, and then integrate it, multiply by pi, and that will give you the volume of the solid generated by rotating it about the axis. Okay, so let's look at an example. Or two.
Or three.
So this says the region in the first quadrant bounded by the graphs of y is equal to 1/2 x cubed and y is equal to 2x is revolved about the x-axis. Find the volume of the resulting solid. Okay, so first thing that we need to do, let's look at the graph. So put the equations into your calculator and graph them. And I've got a cubic equation. And I've got a linear equation. And after I graph them, I'm going to label a couple of things so that I don't get confused. So I have my top equation, I have my bottom equation, and also I'm going to find the intersection because I will need that for the bounds. So they intersect at 2, 4. Yes. And let me explain again why this is a washer and not a disc. Okay, so let me go back to the disc problems real quickly. And I want you to look up here. So in the first problem, my bounds were from 0 to 2 on the x-axis, and the entire shaded region is flush, touching, okay, the axis of rotation from 0 to 2. So if that is the case, it is a disk because there's no place for the hole. Same thing on the next one. I integrate with respect to y, and it goes from 0 to 1. And this entire shaded region is flush up against the axis of rotation from 0 to 1. It's touching everything on the axis of rotation from 0 to 1. Therefore, it is a disk. However, here, okay, this gap in between the lower equation and the axis of rotation creates the hole. Therefore, this is a washer. Does that make sense?
Yeah.
So if it's a washer, I'm going to use my washer formula. Pi times the integral. The bounds, it's with respect to x, so I need x bounds. So the origin at 0 and 2, the intersection point of the two functions. And I plug in my top equation, which is 2x, and I square that. I'm going to subtract, since I got to subtract off the whole. I plug in the bottom equation, which is 1/2 x cubed, and don't forget to square it. And that is with respect to x. So let me clean this up a little bit. I got pi integral from 0 to 2. I could write this as 4x squared minus 1/4 x to the 6th. Squaring both of those functions. Although if it's calculator, you certainly don't have to. And I put that into my calculator.
So this is like its own little thing, right? Like there's no like cross sections involved. Or is it?
It's not. It is separate.
It's easier than one.
I like this one more, yeah.
All right. And let's see, as an exact answer, I got 128 over 21 pi, or as an approximation, it's 19.149.
Eliza knew it. Keep saying.
Jacob, please don't say.
I know I did.
All right, one more. This time we're going to rotate about the y-axis. The region under the curve, x squared plus 1 equals y, and bounded by x is equal to 2 and y is equal to 1, is revolved about the y-axis. Find the volume of the resulting solid. Okay, so let's sketch the graph. We probably don't even need a calculator.
Yes, we are.
And even some people that have calculators don't use it, right? So I've got x is equal to 2, which is the vertical line right there. Y is equal to 1 is going to be the horizontal line right there. And then this is a parabola that has been shifted up 1. So it's going to start right there and then be a parabola. So we are talking about this region right here that is enclosed by those curves. And I also need my intersection point. And I could get that by taking the 2 and plugging it in. So I know that this is 2, 5. Okay, now it is revolved about the y-axis. So if that's the case, let me label it. This will be the top. This will be the bottom, right to left. Also, I know that it's a washer because there's a big gap there between the bottom equation and the axis of rotation, which is the y-axis. The last thing that I need to do, since it's with respect to y, I need to take this equation and solve for x so that I have y's in my integrand. So I've got x squared plus 1 equals y. So x squared equals y minus 1. So x equals the square root of y minus 1. And it's plus or minus, but I can throw out the minus because we're in the first quadrant. And so now I'm ready to plug into my equation. So volume equals pi integral. What are the bounds? Be careful. 1 to 5. I need y bounds. And it's bounded below by y is equal to 1 and above by the intersection of the two functions. Okay. Now I'm going to plug in my top equation, which is x is equal to 2. So I've got 2 squared. And then subtract the bottom equation squared. So I've got square root of y minus 1. Brackets with respect to y. And I'm going to clean this up just a little bit so that it's a little easier. I've got pi integral from 1 to 5. And let's see, that's going to give me 4 minus the radical and the square will cancel. And then distributing the negative, I'm going to have 4 plus 1, which is 5 minus y, dy. Now you can put that into your calculator.
I'll do it. I'll do it actually.
The easy one, right?
Times 5. What was it there? 8 pi.
I was on pins and needles there waiting for your answer. And yes, it is 8 pi. Okay, so final thing, just a little summary. Disk, to use the disk method, the entire area being rotated, must be flush against the axis being rotated. I would hope it's not new, just used in a different context. Because the washer is not flush. And then we're going to subtract bottom from the top. Of course, those are squared because they are the radius of our surface.